Hey there kids, welcome to another math video. This is Eureka Math Grade 5, Module 3, Lesson 9, homework. And today we get to drop the area model from our addition problems. So yay, you'll get to save time on that. But if you're not quite sure about the skip counting method, you're going to want to pay close attention as we go through this. Hopefully your homework is already done, and then you can fix any errors as we move forward. So we're adding fractions, making like units numerically, which means a common denominator, and we're going to use numbers to figure that out. So make like units and then add. So first thing first is that you look at the two bottom numbers. The strategy, if you go watch the problem set video, I laid it out very carefully and clearly in that video. It's a skip count strategy. If this is your scale factor up on here, how many times do I have to multiply these numbers in order to get to that common denominator point? So 5 times 2 would be 10, 5 times 3 is 15. 3 times 2, we'd have 6, 9, 12, 15. And so the scale factor is going to be up here. Now that's if you show all your work. Now pretty soon we're going to drop that off because you're just going to be skip counting and you'll show the equivalent right below. So this is what you should be thinking about when you're trying to find that common denominator. Now here's the common denominator. Okay, so if I put I'm going to rewrite over here so it's neater. If I put my new common denominator just below each fraction that's going to be the equivalent of that one, then you have to use the scale factor and multiply both the top and the bottom in order to get the equivalent fraction. So if 3 times 5 is 15, okay, so 5 is going to become 3 times larger to have my 15, then I also have to bring along my numerator at the same rate. If you don't know what I'm talking about, go watch the problem set video so you can see that the ratio between the top fraction and the bottom have not changed. The ratio is the same. Here I have a different scale because I had 3, so I have to have a different scale. That's where the 5 comes in. In order to change my 3, I have to multiply by 5 to get to 15. Therefore, I have to multiply by 5 on the top. Now I'm going to be working a lot of these problems downward, which is when you get into algebra, that's how your work should look. So I don't always go straight across anymore. 9 plus 5 is 14. And you end up with 14/15. Circle your answer if you didn't already and move on. Or check and make sure, go back and see what you did wrong. All right, so for the next one, when you do your skip counting, first of all, you want to think about, when I skip count by 5 and 11, do those have any numbers in common that are multiples? Now 11's a tough one because what I'm looking for is something that I know is a multiple of 5, and multiples of 5 are only 5, 10, 15, 20, 25, 30, etc. And since I know that when I have multiples of 11, they're doubles, this one's pretty clear that I'm going to get all the way up to 55, which is these two multiplied by each other, before I have a common denominator. Okay, so once you see what your multiple is going to be, go ahead and write that, and then use the scale factor, which sometimes is just going to be the other number. For this one, it is. And use that as your scale factor. This goes back to where I said that cross multiplying. So if I have to get from 5 to 55, I'm using 11 as my scale factor. Therefore, I use 11 for my 3, and there's my 33 new numerator equivalent fraction. If I have to use 11 as my denominator here and get to 55, then my scale factor is times 5, which is right here. Multiply 5 times 1 to get 5. So you're increasing the value of the pieces by the opposite denominator. 33 plus 5, 38. And you probably are going to look at this and go, gee, can I reduce that? Can I simplify? I've got an even number. I have an odd number. After a while, you realize there are some things that just can't be simplified, so we'll move on. This one does not need to be simplified. All right, now between 9 and 6, so you don't have to multiply this. if you think about multiples, what is 9 times 2? Well, that's 18. You should know that 6 times 2 is 12, but 6 times 3 is 18. As soon as you have that common denominator, that's what you're going to use. Use the scale factor on top. Okay, if you've written it all out, it should look something like this. If I want to get from 9 to 18, that's a scale factor of times 2. So 9 times 2 is 18, 2 times 2, 4. If I'm going from 6 to 18, my scale factor is 3. So 3 times 5 is 15. So you're using the scale factor on the top and on the bottom in order to get your new numerators. Now, when you add these, you might notice, gosh, I have an improper fraction. That's okay. We're going to straighten this out just like we did a couple videos ago by using those mixed numbers. How many 18s can I fit into 19? I can fit 1. What's the difference between these two? 1 out of 18. And that's your final answer when you change this from an improper to a mixed number. Now here we have 3 add-ins, which is fine. You can line up all of your, sorry, I got that. I was all excited about the 10. You can line up all 3 of your denominators here, but what I want to show you is that if you use the largest number first and you get a multiple that's really low with your scale factors, then all you have to do is figure out what is the scale factor to get this one there. Well, 4 times 5 is 20, and 5 times 4 is 20. And so knowing your multiples is so critical here. It is so critical. If you don't know your multiples, this is going to be really difficult, honestly, because you won't recognize that you can do things much, much easier. You might be somewhere up around 40 or 100, and students who get that high are likely to make more errors when they're trying to simplify as to bring it back down. So anyway, what is the scale factor from 5 to 20? 5 times what is 20? Well, it's 4. Use the 4 for the 2. 4 times 2 is 8. How do I get from 4 to 20? Well, from 4 to 20, that's times 5. Therefore, 5 is my scale factor. Multiply 5 times 1. How do you get from 10 to 20? It's times 2. 2 is your scale factor. 2 times 1, 2. Adding these up, I always look to make a 10. 8 and 2 is 10, plus 5 is 15. Now I have 15 20ths. You might be thinking, I think I can simplify that. Even though I have an odd number and an even number, I could divide both by 5. As soon as you see it, as soon as you know, you want to have that common divisor and simplify by the biggest number you can. 15 divided by 3. 15 divided by 5 is 3. Oops, gave it away. 20 divided by 5 is 4. And that is your simplest form answer. Next one. All right, so for 3 and 5, we did that up here on top. And so also noticing when you've already done the work, don't redo it. My goodness, why would you want to spend all that time? 15 is your common denominator, and that's using the other number as your scale factor. So this one's really easy. 5 times 1 and 3 times 7. It doesn't matter that it's bigger than the denominator. We're going to straighten it out with our answer. 5 plus 21, 26 15ths, and then how many times can you fit 15 into 26? Remember, this is always a division problem. 1 full time, because 2 15s make 30. So I'm 4 short of 2, which should give you a clue about what is the leftover amount between, or the difference between 26 and 15. And so you have 11 is the difference, and this is your mixed number answer. All right, now when we have 8 and 12, you sure don't want to have to multiply this. And can you imagine having to make a model with 12 and then laying over 8 pieces and vice versa? No. So you take your 12 and your 8 and you go, okay, I'm starting with the largest number. Always start with the largest number. 12 times 2 is 24. That is a multiple of 8. 8 times 3 is 24. I want to use 24. What is the scale factor? 8 times what is 24? Scale factors up here, it's 3. Take that 3 and multiply it by the 5 to get 15. What is the scale factor for 12? It's only 2. I'm only making it 2 times bigger here, so 7 times 2 is 14. When you add these two together, 29 24ths. And then we're going to straighten this out, not leave it improper. I could fit 24 into 29 one time with a difference of 5. Always look to simplify, but there's nothing that we can do to make that any simpler because there is no common divisor. Okay, next one. Now they give us a mixed number here. That's okay. The important thing with the mixed numbers is to just not lose track of them. Okay, so what I want you to do is just put the 1 down here. Don't lose track of it. I want you to separate it from the problem so that we then have 2 other fractions. Now, if you were checking your homework and you already did it, but you didn't do it this way, it'd be nice if you could just make note of how to keep track of that 1 so you don't forget about it. Now, 12 is my common denominator here. You can get there by skip counting. 4, 8, 12. Yes, 12 is a multiple of 3. 3, 6, 9, 12. Here they both are, okay? What is the scale factor? To get from thirds to 12ths, that's times 4. 4 times 1 is 4. Sometimes you can cross multiply and sometimes you can't. This time we can because our scale factor is the other number. 3 times 3 is 9 because 4 times 3 gets you the 12, therefore 3 is our scale factor. So bring down your whole number. Bring it down while you add this and while you notice this is an improper fraction. Straighten it out into a mixed number and then get your final answer. And that way you won't forget about that 1 which you probably forgot about. Once people get going on all this, find the common denominator and add these up, a lot of students will just leave this and have 1 and 1/12 as the final answer. I bet there are some of you who did that today and you're like, whoopsie. Okay, so 2 and 1/12 is your final answer here. And on this one, again, keep track of that whole number. So we're going to have 5 sixths plus 1 plus 1/4. You can move the 1 to the side. It doesn't matter as long as you keep track of it. What would be the best common denominator between 6 and 4? Well, if you look at 6 times 2, that's 12. And that is a multiple of 4 when you use 3. So I want to use 12 for my common denominator. 6 times 2, therefore 5 times 2. 4 times 3, therefore 3 times 1. Add up your top fractions, your numerators on top. That gives you 13/12 plus 1. This is starting to look familiar, isn't it? Okay, so this is 1 and 1/12 plus 1, which equals 2 and 1/12. There you go. Okay, on to the word problems. Yay. On Monday, Ka practiced guitar for 2/3 of 1 hour. When she finished, she practiced piano for 3/4 of 1 hour. How much time did Ka spend practicing instruments on Monday? So remember we were talking about that labeling and what if I have one thing and then I have another thing and we have piano and guitar, but those are both called instruments, so we want to be able to combine our 2 fractions. Okay, so if I have 2/3 plus 3/4, I need a common denominator. I just wanted to jump right in. 3 times 4 is 12, so I can use the other number as my scale factor. That is the lowest that it would be because 4, 8, 12. 8 is not divisible by 3, so we're going to be at 12 already. So when I have the other number as my scale factor, I can use that to cross multiply. It really helps me do things quickly. 4 times 2 is 8. 3 times 3 is 9. Add those two and get 17/12. That's improper, so straighten it out. 12 fits into 17 one whole time, with the difference between here being my new numerator And then my denominator is my label, so I bring it over. So how do I label it? These are the fractions of 1 hour. So this is how many hours? 1 full hour and 5/12 of the next hour. So it's going to be 1 and 5/12 hours, or ka practiced. 1 and 5/12 hours on Monday. And if you have words in the problem, you should have words in your answer. I think I say that every single day. Okay. And I hope these videos are helpful. Click subscribe and come back again. That's my one little plug that I like to throw in there. All right. Ms. Howe bought a bag of rice for dinner. She used 3/5 kilogram of the rice and still had 2 1/4 kilograms left. How heavy was the bag of rice that Mrs. Howe bought? Ms. Howe. Again, if you're not quite sure what's being asked, set up a tape diagram. She used 3/5 of a kilogram, and she still had 2 1/4 kilograms left. They're asking you for the total. This is an addition problem. 3/5 plus 2 1/4. Keep track of your whole number while you get your common denominator. You can separate it like that. It makes it nice and easy. Don't lose track of it. Excuse me. Okay, 20 is going to be our common denominator. I should have my coffee closer right now, and I just have my water. The other number is your scale factor. 5 times 4 is 20, therefore 4 times 3 is 12. Okay, 4 times 5 is 20, therefore 5 times 1 is 5. Combine those two numerators, and don't forget your 2. And so now you've got basically your answer, because they were just asking for the total. So now we just need to label it kilograms. 2 17/20 kilograms was the weight of the bag. Of the rice, the bag, whatever. The bag, the rice, the bag of rice. Okay. And finally, Joe spends 2/5 of his money on a jacket and 3/8 of his money on a shirt. He spends the rest on a pair of pants. What fraction of his money does he use to buy the pants? So again, make a little tape diagram if you want to see. We've got the jacket. We've got the shirt. We've got the pants. And all that was the money, Joe's money. Okay, so each piece has its own label. 2/5, 3/8, mystery. And so if you want to know this, we're going back a couple lessons. We have to do 2 steps here. Combine what you know. We need a common denominator. Between 5 and 8, if you were to line these up, and you skip count by 8, because I always start with the larger number, and then I say, is this a multiple of the smaller? Is 16 a multiple? No. How about 24? Nope. 32? Nope. 40? Yes. 5 times 8 is 40. So I know I have to use the other number as my scale factor, okay, which makes it kind of easy, because 5 times 8 is 40, therefore 8 times 2 is 16. Another common error is that students will mix up the order of the addends as they change the numerators. Please don't do that. Just don't. It kind of causes problems later. Anyhow, 8 times 5 is 40, so 5 times 3 is 15. When you add those up, you will get 31/40. Now, what did we find out? That was how much was spent already on the jacket and the shirt. And if you label everything as you go, then it kind of makes things a little bit clearer, but that's not the final answer. That's only part of it. That's this. The question is, what fraction of his money does he use to buy the pants? So what do we do now? How do we find out what fraction to use? Remember that whatever the denominator says, that is your whole. Okay, so all his money is 40/40ths. I need to take away or find the difference between all the money he had, which was up here, and the 31/40ths that's spent. Okay, so that's just a simple subtraction problem. And that's how you can say he spent 9/40ths of his money on pants. There it is. Finally, drop the last word. All right, so that's it. And I hope this is helpful, and I hope you guys understand how to do it. Remember, a true sign of if you really understand this is, can you tell someone about your assignment? Can you tell them how you did it? So anyway, I hope this is helpful. We'll see you on the next video. Bye for now.